Good afternoon and welcome to today's presentation, Preparing the Case for Safety Through Design. Before we begin our presentation today, I would like to take a few moments to go over some housekeeping items. We will be recording this webinar, and this webinar is CLE approved, and we will be asking that you enter a passcode for CLE credit a few times throughout the presentation. In today's webinar, Mr. Paine will discuss contractor requirements as set by OSHA, compliance duties that are owed to every employee, training requirements, job site pre-safety and safety planning, and how to identify potential safety hazards. To give you a little background about our presenter, Daniel Paine, he is the president of Innovative Safety LLC. Mr. Paine has extensive experience as a leader and member of many industry and governmental advisory committees addressing safety standards and regulations. He was the founder of a union ironworking construction company which operated throughout the United States doing installation of fall protection products, specialty rigging, personnel and debris netting systems, and other related construction activities. Mr. Paine is a member of American National Standards Institute, National Safety Council, and American Society of Safety Engineers. For those of our attendees who require a code word for tracking purposes, the code word for today is OSHA. During the presentation, we will take short breaks, and during that time, we will ask that you enter this code into the Q&A widget for CLE reporting purposes. The Q&A is located to the right of your screen. Please remember that if you are applying for CLE credit, you must log onto your computer as yourself. Also, please remember to complete the survey that will appear on your screen at the end of the presentation. As a provider of CLE credits, we are required to have supportive information that you have attended, and in many states, the survey is required. CLE certificates will be provided within 24 to 48 hours via email. Also, the PowerPoint slides can be downloaded from the resource list on the left of your screen. Mr. Paine welcomes your questions. Please use the Q&A widget to submit your questions throughout the presentation. We will take intermittent breaks so that Mr. Paine can respond. Thank you all again for attending today, and Daniel, the presentation is now turned over to you.
Good afternoon, ladies and gentlemen. My name is Dan Paine, as she pointed out, and I'm going to be doing the presentation for you today. And we've entitled it, Preparing the Case for Safety Through Design. Now, what exactly does that mean? Well, it means that anything that you're going to do, you need to have a design and you need to have a plan. Unfortunately, in the past, safety hasn't always been planned well, and that has resulted in numerous accidents and incidents over the years. However, what I plan to do today is to show you how a safety plan can be put into effect, what it looks like, and what you would do, and if you did those things, why you wouldn't have or shouldn't have any unforeseeable accidents or incidents. In addition to that, what we will get is we'll take a look at it and look at those parts of it that if you don't do them and you don't do them correctly or you don't follow them, why that results in an accident and how you can use that to your advantage. Okay, the first thing we're going to look at is the analysis of the case. And I'm using the minimum standards of OSHA, and I use minimum because those are the ones required by law. But by contract, in any contract that one contractor goes into with another or with the owner, there can be additional requirements. And those additional requirements, as long as they're more stringent than OSHA, must be followed. So the first one that we're going to talk about is what they call Section 5A duties. It's also called the General Duty Clause. You can find that right under the OSHA Act if you go to the OSHA webpage, and it looks like this. Each employer shall furnish to each of his employees employment and a place of employment which are free from recognized hazards and that are causing or are likely to cause death or serious physical harm to his employees. And, in addition, he shall comply with the occupational safety and health standards promulgated under the Act. So those are the basic requirements for OSHA between an employer and his employees. And keep in mind that's what OSHA covers. It only covers those safety situations which have to do with an employer and his employees. Now, you will see as we go through this particular presentation that OSHA also has defined employer differently than a lot of people might think it might be. In other words, all levels of contracting are employers. So although you may have an employer who you work for, okay, as an example, the general contractor also has duties and obligations to you, and those duties and obligations must be taken into consideration as well. Those rules can be found in OSHA under compliance documents, and they're under a 1999 document called CPL 2-0.124, which is multi-employer job sites. Obviously, if you're going to have multi-employers, you have to have multi-employers before the rule would apply. Now, let's take a look at what OSHA has to say about accident prevention responsibilities for contractors. And you've got there in blue, if you go to OSHA and you go to 29 CFR 1926, that's the construction standards. You go to the ones that are listed here, you will find these. So accident prevention responsibilities, it shall be the responsibility of the employer to initiate and maintain such programs as this may be necessary to comply with this part. Such programs shall provide for frequent and regular inspections of the job sites, materials, and equipment to be made by a competent person designated by the employers. Now, we're going to talk about that a little bit in the next slide or so, but the important thing is that not only do you have to have a plan, but in order to have a plan and have it implemented and be followed, you need to have frequent and regular inspections. And those frequent and regular inspections need to be done by a competent person. Now, here's how they define a competent person. Competent person means one who is capable of identifying existing and predictable hazards in the surroundings or working conditions which are unsanitary, hazardous, or dangerous to employees, and who has the authorization to take prompt corrective measures to eliminate them. So not only does he have to be there and know what's wrong, but he has to be able to correct those conditions. That has to be given to him by his employer, obviously. A qualified person is a different kind of person. That has to do with the qualifications of a person who's going to do training or who's going to do a job or direct a job to be done. And that means one who, by possession of a recognized degree, certificate, demonstrated his ability to solve or resolve problems relating to the subject matter, work, or the project. Now, let me give you an example of what they mean by that. You can also find in most ANSI, those are American National Standard Institute standards, you can find that they break down qualified persons into different kinds of categories. For instance, if you are going to pick an anchorage point of 5,000 pounds, which would be required, let's say, for a fall protection anchorage point, then that qualified person, if you go to the different ANSI standards that are there, for instance, ANSI 10.32, which is the fall protection standard for construction, it requires that that qualified person be a registered professional engineer. Now, does he have to be on the site? No. But he has to mark on the plans at what phase of construction that is a good anchorage point. Now, let me just explain that a little bit, because we're going to get into this more as we get down the line in the planning part of it. Because something happens to be able to withstand or 5,000 pounds worth of force, when you're building or constructing a structure or building, the points that you can attach to change. For instance, you can have an I-beam that isn't connected to anything. It's being lifted. It doesn't have that integral strength to protect the person. It's not until it gets put in place and bolted up that it gets to that point. And at that point, he has it marked, and the drawing should reflect that that's when you can put an anchorage point in that location. All right, safety, training, and education. And it says that the Secretary shall, pursuant to Section 107F of the Act, establish and supervise programs for the education and training of employees in the recognition of avoidance and prevention of unsafe conditions in employment covered by the Act. Now, what has happened with that particular part of the law is the fact that a lot of different programs have been put together. And a good program in any situation, an employer and a job site and an owner need to require that the person who's going to do the work is trained. If a union employee comes on board, all you have to do is look at the union records. Union records, which are subpoenable, can tell you what training each individual on that job has, and therefore you know whether he's qualified or needs additional training. The training that you're going to get also needs not be generic, but site-specific. And what I mean by site-specific, it does you no good to give somebody elevator training if they're going to work in a building that doesn't have elevators in it. It does you no good to do training on generic types, for instance, of fall protection, if in fact what you're going to use is a specific type of fall protection. And in that case, you need to have that person trained specifically in that, to use that equipment. Now, the rest of that particular statement there says unsafe conditions in the employment covered under the Act. So, when you put together that training program, and we're going to talk about something called the job safety analysis in a few minutes, that means you have to memorialize in writing what in a JSA, and it needs to be kept on a job site, which will say what the job is or task is that those employees are going to be accomplishing, what training they received, okay, and what the hazards are. They need to list the hazards, because obviously the employee can't protect himself if he doesn't know the hazards. On the other hand, if he does know the hazards and he has been trained, that helps the employer out. If he hasn't been trained, that helps the plaintiff out. All right, training requirements. The employer shall instruct each employee in the recognition and avoidance of unsafe conditions, regulations applicable to his work environment to control and eliminate the hazards or other exposures to illness and injury. That's just what we covered. And the employer must train each affected individual in the manner required by the standard, and each failure to train an employee may be considered a separate violation. Now, what is that getting at? That's getting at the fact that we just talked about before. The fact you have generic training means absolutely nothing. What means everything is that you know what you're supposed to be doing in the job that you've been assigned to do. And if you don't know that, then you don't know anything. All right, let's go in and take a look at pre-project and pre-task planning. Now, there is a very good ANSI standard, American National Standard Institute, and you see after that slash on there, ASSE, which stands for the American Society of Safety Engineers, A10-1. Now, what is A10-1? Well, let me tell you what it is. It is pre-project and pre-task safety and health planning. I'm looking at it right now. And let me just highlight some of the important things which you're seeing here. The owner's pre-project planning, okay? And what it says in this standard, among other things, the construction owner shall ensure that the project-specific expectations, goals, and policies for safety and health are established for the project. The owner shall ensure the project-specific safety health plans are implemented by the project constructor and evaluated for necessary changes throughout the project. Also, what it says is that the owner should be talking to the architect to ensure the fact that the contract reflects what he wants done. All right, let's look at the next one. Project constructors. Those are the people who are going to be the general contractor, the prime contractor, etc., and what their duties are going to be. So, what the project constructor needs to do is he needs to take a look at what the contract documents look like. He needs to have a meeting with the owner, the engineers, and the architects to decide what he has facing him. And then he needs to break that job down in order to bid the job, in order to make sure he's going to make money, as well as the job is going to be run safely. So that means he does, during his normal planning, break that whole job down. What he needs to do in today's environment, he also needs to outline what the safety plan is going to be. Now, the way that's done right up front, and we'll get into this in a few minutes, is that the owner usually incorporates either into the documents or has the architects and engineers put forth what they call a site-specific safety plan, which means they take a look at all the different things that are going to be done, and they tell each one of the subcontractors who are going to bid on this job just exactly what they need to do, because that's part of what they're supposed to get for a contract. But he also needs to tell them that he wants a site-specific plan from each one of them. In addition, he has the responsibility to make sure that those site-specific plans are coordinated. What I mean by coordinated, let me give you an example. You've got a crane on the job site. You have numerous different contractors on the job site doing different things. Whoever is operating that crane is going to be picking up material and moving it around. One of the things that he has to do is to make sure that those plans take into consideration what they're going to move, when they're going to move it, and what the path of that is going to be, so that it doesn't go over top of other employees that are working in that particular area. That's just one example. You can see from that if you do your job right, the plan comes out, you're not going to have one contractor interfering with another. You're not going to have a bunch of people out there with lifts and other tools of the trade who are getting in each other's way and causing accidents. You're going to see that before somebody uses certain kinds of equipment, and the ground is all rough from other things that have taken place, that area is level and smooth, so that when you go in with those lifts, you have a level surface. Those are just some of the kinds of things that goes into pre-constructor, pre-project planning. Now, the project constructor's pre-task planning is those tasks which he is going to provide, they need to be pre-planned. And you're going to need to have those tasks pre-planned in different ways. And one of the things that you do is a job hazard safety analysis. And we will get into that in a few minutes. But again, what I want to point out is when you do a hazard analysis on a job, it says, for instance, in another standard, which is American Standards Institute A10.33, which is a multi-employer job site projects, it tells you how you do this, how you do a hazard analysis in a project survey. So let me just quickly hit that. A project survey is prior to the start of the work. Each contractor shall conduct a physical survey of the job and make a survey of the work to be performed by reviewing the drawings, conducting discussions as applicable with one or more of the following: the owner, the engineer, general contractor, and construction manager. And then he's to do a hazard analysis at the initiation of the construction project, and for critical stages of work, a hazard analysis shall be conducted and implemented describing potential hazards, actions required to provide a safe and healthy workplace. And then he needs to have a meeting of the affected contractors shall be held to coordinate and assign responsibilities for all the items identified. So that becomes very, very key to what takes place from the contractor's point of view. I see that also is what we're talking about in the last one there for the task hazards and analysis guidelines. And keep in mind, the same thing, including a site-specific plan, goes down to the subcontractor level as well. So that when you get through, you have each person with a plan, a safety plan, as well as a plan for how they're going to do their work. So you have something to look at. You have something to evaluate. And then if something does go wrong, you can take a look at what was supposed to happen versus what did in fact happen. Okay, I decided at this point, let's take a look at some things that would make sense. Now here's a guy on an overpass. You can see him walking, and if you look carefully, unfortunately I don't have a pointer in this presentation, but he's attached to a lifeline that goes the length of that bridge. And that's designed to make sure that he doesn't fall and hit the ground, obviously. And as you can see, there is a truck coming in. This obviously was not taken into consideration because the next slide shows what happens. He doesn't hit the ground, he's in good shape, but whoever was doing this hazard analysis didn't take into consideration that he was going to have those kind of hazards there. That was a case of not really appreciating doing an in-depth hazard analysis. Seems simple, happens every day, and that's something that you need to have in a detailed hazard analysis. You either divert the truck or have it diverted, or you use some kind of fall protection method, such as guardrails or something else where you can't fall off the edge of the area he's working in. All right? This is a real situation that's out in Wyoming where they were putting telephone poles up, and they put them so many feet apart, and they put one right in the middle of the road. I didn't bring or put in here the rest of the pictures that went with this, but hard to believe as it is, that road that's a dirt road there then got paved, and the pole was still right in the middle of the road. Good job of pre-planning. Okay, here's another example that you see probably all the time. You have someone dig a trench. There are rules on how you dig a trench. You can't dig a trench that's more than 4 feet deep without doing something. This guy's got all the materials from the trench piled up on the other side of the trench. They can roll, fall in, and hit him. In addition to that, that trench could collapse. It's not tiered, so therefore it must be supported. And he can support it either by putting in a plank wall, or he could put in a trench box. Either one could go in there and he could do a safe operation. Doing it the way he's doing it is an accident waiting to happen. And obviously nobody thought about it, or maybe even worse, cared about it. Okay, here's an example. You see this kind of thing all the time. Guy's got himself up a scaffold, and on top of the scaffold he puts a ladder. Now, if you take a look at it, there's all kinds of violations here. Not only does he have the ladder on the scaffold where it can fall off, but it's an A-frame ladder, which you can't use unless it's opened and latched. It's got closed, standing up there. Why don't you want to do that? in any instance, even if it's on the ground, is when the ladder is closed, the rungs are at an angle, not flat. It's only when you open it up that they flatten out. And it's also got it leaning against the glass in a window. So that's just an accident waiting to happen. Okay, here's an interesting one to take a look at. And what we got here is we've got a ladder with both the do's and the don'ts. And if you can, I don't know if you can read what's there. So what I'm going to try to do for you here is to go through what's really there. But on the one that's on the top, what it says is the right way. And the right way is you want to have the ladder that's the right height for the job. And in this particular case, he's not going up on the roof, so he has to make sure it's up there. And you can't really see it in this picture, but there is a standoff on that ladder so that it doesn't hit the gutter, okay, but is supported by the wall itself. Should he be going to go up on the roof, that ladder would have to extend 3 rungs or 3 feet above that roof line so that he would have something to hold on to when he got off of the ladder. He's also got proper shoes on, which you probably can't see too well. You want to make sure that steps are clean, and you want to make sure that there's an overlap of 3 rungs, which you can see where the 2 ladders come together. Otherwise, you don't have it stabled. The ladder's undamaged, and you have an adult at the foot of the ladder to support it. If you don't have an adult at the foot of the ladder to support it, and it was going to be in place permanently, then you'd have to have a cleat arrangement to hold it in place. Okay? And the ladder is at the correct angle, which is a 1 to 4 or a 75-degree angle. The reason for that is more than that, it's going to slide down the roof, down the building. Less than that, it's going to put the individual at a disadvantage, and the ladder can slide sideways, and he may fall off of it. And he's got a firm, level base, and they have 2 non-slip feet on the bottom of the ladder. That makes it right. Now, if you look at the one below it, you see there's an electrical hazard there, and he shouldn't be climbing the ladder where there is an electrical hazard unless it's been shut off or covered, and that's what the overhead hazard would be. He's got the wrong height for the job. He's way more than 75 degrees away from the building, and he's standing on the top 3 rungs of the ladder, and he doesn't have the proper overlap of the ladder on the bottom. I mean, in the middle. And he's got an unstable surface because he's got it up on that piece of planking, and the base is too far, as we've pointed out before, from the wall. So these are some of the things you need to take into consideration when you're putting a ladder up. And anybody who's doing training of anybody needs to make sure that people have training, even more extensive than this, in ladders before they're allowed to use them. Because in most cases, a ladder is considered a safety device by itself. Of course, if it isn't erected properly, it's not a safety device. It certainly is an unsafe device and a hazard. Okay, here's an example of a guy using a restraint system. If you notice, they have what they call safety straps, which you can pour into concrete, among other things. They can also be put over rebar, and which gives you your 5,000-pound anchorage at the top. It hangs down. He's hooked in a lanyard, which is adjustable, so he can adjust that so that he can't go over the edge, but he can do his work in that particular area. Okay, let's take a look at just some other things this is a safety net picture, and a forms and stripping floors. And what I want to do here with this one is to show just how you can pre-plan something. If you notice, there is forms that a crane's going to pick up at the top. The next two floors down have reinforcing bars underneath the floors since they've been stripped, and you can have materials and people come off those floors because they haven't had a chance yet to put up the guardrail system and or finish them off. So what you do is you put a safety net that's only 25 feet or less below them, and then if they fall off, they fall into the net. Tools and other materials fall into the net, and that's a good way to provide safety equipment where you can't provide the normal standard thing that you would use. Here's an example underneath of a safety net showing the cantilever arms, and I guess I can't move this slide, but you can see where that arm comes down to the building, it's pivoted. And so if someone falls into the net then pulls back and bags him so that he ends up in the net, not hitting a cable or the pole. And finally, as an example of something that goes on, we have portable guardrails here. Portable guardrails can be used along a roof where you're doing repairs or you're doing new work or you're putting up air conditioning, whatever, to keep people contained so they don't fall off the roof. They have a top rail and a mid rail, which is hard to see in this picture, and they meet 42 inches and 21 inches, and they have enough weight on the bottom so they meet the 200 pounds of force that they're required to have. Okay, this particular picture shows how you would put nets above, and then when you can do something below, you put up guardrails, and these guardrails also have netting attached to them to stop stuff from blowing or being kicked off of the floors. All right, let's talk now about that multi-employer citation policy we talked about before, that's CPL 2-0.124. We're talking about a multi-employer work site in this particular case. And a compliance document is a document that is put out by OSHA to their inspectors to use. This particular employer's document got challenged in the courts, and there was a case called the Summit case, which went through the 7th Court of Appeals and was upheld. And it allowed the Secretary of Labor to come up with these different categories of employer. Okay, and so I think I got ahead of myself here just a minute. No, I didn't. Okay, so first of all, we're going to define the multi-employer work site. On multi-employer work sites, in all industries, not just in construction, more than one employer may be citable for a hazardous condition that violates an OSHA standard. So we're not just talking about the employer who employs the guy, we're talking about any other kind of employer. Now this has had some pretty good ramifications that have gone with this, because, for instance, New York uses an example. If an owner who is liable down there or a general contractor gives out a contract to subcontractors, he wants to be held additionally named insured. And the reason for that is, otherwise the employer, who may very well create the hazard, is going to not be able to be sued because of workers' compensation. But because of the fact he's going to be brought into the case under additional indemnification, he's back in the case. So that gives some leverage to the people above that employer to make sure that they do the right thing and that they do follow the safety standards they're supposed to follow. Now, on multi-employer work sites, we have different kinds of employers. The first type of employer is the creating employer. That's the employer that caused a hazardous condition that violates an OSHA standard. Now, that might be the person's own employer, or it might be someone like a scaffold employer who comes in and puts up a scaffold for everybody to use, and for whatever reason, it doesn't have the proper guardrails on it, and someone falls off. Then he becomes the creating employer. He's the guy that put it up. He's the guy that caused the accident, not necessarily the employee who got injured. The next type is the exposing employer, and that would be who we'd normally consider the employer, an employer whose own employees are exposed to the hazard. The next employer is the correcting employer, and that's an employer who is engaged in a common undertaking on the same work site as the exposing employer and is responsible for correcting a hazard. This usually occurs where an employer is given the responsibility of installing or maintaining particular safety health devices. A good example, let's go back to the scaffold contractor. He normally gets not only to put up the scaffold, but he's the one that signs off on it, he's the one that inspects it, he's the one that makes sure that the guardrails are always in place and that people don't change it. He's also the guy, when he sees something going wrong, can stop it. He can tag that particular scaffold so no one can use it until it's made safe. There are lots of different kinds of correcting employers. Okay, let's go to the next slide. Now, the controlling employer is the one that we would call normally the general contractor or the prime contractor or the construction manager. He's the one that has the general supervisory authority over the work site. And where it gets interesting is the power to correct safety and health violations itself will require others to correct them. Control can be established by contract, which is the way you'd like to have it established, or in the absence of explicit contractual provisions, by the exercise of control in practice. So if he's doing the job, even if he's doing it wrong, hasn't put into place all the things that should be there, as far as OSHA is concerned, he is the general contractor, and under their rules would be citable. All right. We talked before about the job site safety needs to be pre-planned. And job site safety, as all aspects of life, needs to be pre-planned to be successful. We've talked about that. And I can't emphasize enough, the pre-planning is where it all begins. If you don't pre-plan it, you're going to be in a lot of trouble. And the earlier the controlling employer and consultants plan, the more options will be available, and the better and more cost-effective the site-specific plan will be. If you're doing something by the seat of your pants, it never works out well, because construction continues at a very rapid pace, and you have very few options if you've done it wrong to begin with. Let me give you an example here. You plan on putting the building up, you plan on decking every other floor, so that you meet the 15-foot requirements for steel erectors. However, what happens is the decking doesn't arrive on time, even though you pre-planned it that way. So now what are you going to do? Well, if you pre-planned this thing, you would recognize that maybe it won't come on time, and that maybe what you need to do in that particular case is either to deck it with wood or to put safety nets in those areas, which will give you the same thing. But that means you have to have both readily available. Safety nets are easy to have on a job site, and they're there if you need them. You can take them out and put them up. If you don't own them, or they're somewhere a long way away, chances are somebody's going to take a risk, and chances are that risk is going to involve an accident because they won't have anything there. Okay. Pre-planning needs to start with getting the proper information, choosing the means and methods to accomplish the work. Means and methods are very, very important because once you choose the means and methods, that means how you're going to do the job. Now you know what the hazards are. And then you need to take a look, can you eliminate them? Can you change the work sequence? Can you mitigate them with engineering principles? Or do you need to have some kind of protection that's available? Then, once you've done all that, then you can get the appropriate contractors to do what it is you want them to do. Because the means and methods are how the work's going to be accomplished, and then all those contractors need to know what those hazards are, and so do their workers. You also need to take into consideration things like weather and other areas which lots of people don't pay attention to and then find themselves caught with a problem. It does you no good, for instance, to say you're going to be replacing roofs in New England in January, which is going on right outside my window, by the way, and the temperature is not correct and there's ice on the roof. You've got problems where you shouldn't be there. And so what you need to do is to shut down for that particular day because of the weather conditions. Also, it doesn't give you a very good quality job when you're taking off shingles and putting up asphalt shingles, which are stiff and can break in that kind of environment. So it doesn't make any sense, not just safety sense, it doesn't make any economic sense, nothing. It's just a question, somebody trying to hurry up a job and get it done without paying attention to consequences. All right, we were talking about fall protection in particular. Let's take a look at this particular slide. Many people, unfortunately, believe that when they put on a harness and a 6-foot lanyard with a shock absorber, that they're going to fall 6 feet. Well, that is the farthest thing from the truth that you can imagine. This chart shows you what to do. And if you know this, and anybody that sells that equipment makes this available, that it all depends upon where the anchorage point is and where your feet are. Because where the anchorage point is supposed to be above your head. So you fall the length of the lanyard. Then you fall 3.5 feet when that shock absorber opens. And then you've got whatever the height of the worker is. Let's say it's 6 feet. And then you've got stretch in the system, which gives you 3 feet more. Now, lots of people say, I'm working on one floor and I'm going to tie off because if I fall through the floor or I fall off the beam, the next floor is 15 feet below me. Guess what? You're going to hit the floor. You don't have on a piece of equipment that's going to stop you from doing that. Or you may swing into or hit something else on the way down if you haven't taken into consideration where you're going to fall. Let me give you a third scenario. What's below you, and if you're not hooked in one spot, but you're going to move with this system, does the floor or what's parked under it or placed under it change the dimensions that you're going to fall onto? For instance, if you got a stack of boxes that are somewhere underneath you that you got to walk over that are only 10 feet below you, you know you're in trouble. So you need to take into consideration while you plan. Now, each piece of equipment is different. Let's look at the next slide. Here you can see that if you take this particular slide, I've showed you just for comparison the shock absorber with the D-ring and 6-foot lanyard. Let's go next to it and look at the retractable lifeline. Because of the fact that it locks quicker, you're not going to fall as far. So you're going to fall 14.5 feet. Okay? But let's take into consideration some other things you do. Let's say instead of attaching to a fixed I-beam above you, you have a cable that you're hooking to that goes across. What is the deflection of that cable? How long is that cable? How much further are you going to fall? You need to know all those things. It needs to be part of your plan. Okay, and this one, the idea behind this is to show you just what a fall protection system components look like. Okay? First of all, you have a harness and it needs to fit well. It needs to fit tight underneath the buttocks, and the D-ring needs to be right where it is in the middle of the back. And the lanyard goes on up, and you got to hook it to something. One of the things you can do is to use a strap with a D-ring on it and put it on an I-beam or whatever happens to be above you as an anchorage point. They're designed to do that. You have the right application, they work well. The ones next to it show you that there's different kinds of lanyards. The first one is a nylon rope lanyard. The second one is a webbing lanyard. And the other two are there just to show you that you can have D-rings on the front of your belt on your harness, and those two small hooks hook into two clips on either side of that belt, and the big hook is to use for positioning. Let's say you're on rebar, you hook it into the rebar, you put your feet on the rebar, and you can lean back to do your tie wiring or your welding. Or you can do the same thing with a form and any other uses. Just to show you there's flexibility in what you can do. All right. Job site safety. Once it's been determined what means and methods are appropriate to, let me get there. Once it is determined.
Dan, I'm going to interrupt.
Sure.
Could we just have the attendees please type the passcode into the Q&A, please? Okay, go ahead.
Okay. Once it's been determined what means and methods are appropriate to accomplish the task, then the need to plan on what and where they will be used, and to make sure that the design of the application's means and methods take into account all situations, including the weather and other items. We talked about coordination and joint inspections are absolutely necessary to understand the situation on the site and adjust the action plan accordingly. And all of the defendants, and I'm calling them defendants because if there's a lawsuit, all the contractors will end up being defendants involved, needed to plan and schedule in appropriate equipment, personnel to arrive on time, and to have site-specific plans for the timely application and use of materials and equipment to mitigate all weather-related hazards before the site is opened for work. They do that, they have a plan, you shouldn't have an accident. I think you can all see that. All right. Identifying potential safety hazards. First priority in developing an approach to the problem solving. We've talked about that. I think the second one is very key. Mentioned this, but due to the speed at which construction jobs proceed, time does not allow a single operation to become safe through trial and error. If it isn't pre-planned, they're not trained, they don't know what the hazards are, you're going to have an accident. Pre-phase planning will enable the contractor to anticipate the hazards and develop an appropriate plan to prevent accidents. I think this is a good place to break and take some questions.
Okay, our first question is, are all small contractors required to have a design plan or limits for size of project or number of employees of the contractor?
The answer is yes, they are, and to the degree, depending upon their size, they can do something that's very simple. We're going to talk about this in a minute. There's a one-page form which you can use, which will allow you to put down what means and methods you're going to use, okay, what kinds of equipment they're going to use for safety if they need it, and what the hazards are. Then what all that foreman does is sit down with his men, talk about those things, make sure he knows how to wear the equipment and how to do the job. And that really covers pretty much what you need to do. It's much more formal the bigger the job gets, because there's many other kinds of people that have to interact with you. But if you're just putting in windows or doing roofing work, and it's the same thing over and over again, all you do when you put this together is you look at the plan that you put up for how you're going to do your roofing, and then you make sure that there are no exceptions, because the exceptions are what kill you. If you've got a way different pitch roof, or you've got overhangs that you normally don't work with, you need to have a plan for those.
Okay, we have another question. Does the statute apply to government employers?
The statute does apply to government employers, yes.
Okay, we're running low on time, so we're just going to skip to the next slide then.
Okay. All right. Job hazard analysis, which someone asked a question on, and I want to just cover this fairly quickly for you. But this is covered in a number of places. You can go to A1033, which is multi-employer job sites, or you can go to A10.32, which is the standard for fall protection. It's in that. Or you can go to the new A1011, which is the one for safety nets. All of them have what you're going to use for job hazard analysis. They give you the forms and how you do it. This has become important because almost every contractor today of any size requires this, especially if he's got subcontractors. Okay? Here's what's in it. This is the opportunity you have to how you're going to accomplish the task, how many people involved, and the potential problems and opportunities. So in other words, when you're setting your job up, if you're going to have a roofing crew, or you're going to have a decking crew for ironworking, or you're going to have a framing crew, you know how many people are on that crew. You know how many people you're going to use. So you take that into consideration as you go. And if there are other situations that are there, you're in a bad weather situation, or in an area where there's bad weather, or other issues, you need to cover them. So each task needs to be described in brief, simple language. Remember, from the description, the subcontractors will need to be able to communicate the expectations to the foreman and workers, train them, and be able to determine the time and costs as well as the potential hazards. Okay, evaluating the hazards. We talked about this in the big general picture. Let's talk about it in the small picture of what we're going to do here. Prior to the start of work on the project or the phase, each employer, he will conduct a survey of the job site. I'm talking about his job site. If he's going to go put a new roof on, what he needs to do is go inspect the roof that's there. If it's a new construction building, he needs to take a look at the plans and decide what the heck it is that he's got to do and what are going to be the conditions. Okay? And then he needs to talk to the owner, the engineer, and the general contractor to see what their expectations are, so that you do it in accordance with that, you can do it safely. This is the form I'm talking about. It comes in different sizes and laid out probably better than I've done here, because I wanted to get this particular thing all on one page for what we've got. But you can see from where we are here that, and it's a one-page form just like this. So what you've got is, it says, on-site evaluation of a task or operation to identify potential hazards, determine the necessary controls or breakdown of the TASA operations. Now these words come directly out of those three standards I just gave you before. The form is set up on a page. It's easy to put out. You put date on it, you put the worksite description, and then you give a very simple activity description and describe each procedure and the result. What you don't want to do is to have a procedure that you're going to do and not have it covered. That's where a lot of people get into problems. So then you identify the hazards with whatever it is you're going to do. You make sure you identify the equipment that's going to be used, and then if there's controls and inspection procedures, you just list them. And then you list the crew that's assigned, the foreman, the competent person with their job duties. And then you have a little discussion here of what you're going to talk to everybody about, what those hazards are that they need to know about. And then you get approval. And the approval comes down to, did you do the specialized training or hazardous training that's required? And that way, you know it's site-specific. I see more trials come up over the fact that somebody didn't do the training that was necessary. Somebody will say they were untrained or they didn't have sufficient training or whatever. That should never be an issue. You should make sure that training is done. Then you have the responsible supervisor sign off on this is what we're going to do. The competent person signs off, this is what we're going to do, and then that contractor approves it, and in most cases, it's necessary that he keep it there so that anybody else, another contractor, including the general, can come on and just flip through them, see that what's supposed to be being done is being done. That's the form. All right. Again, job hazard analysis, unsafe conditions or things. So the defendants need to concisely define what is unsafe, perhaps what laws, regulations, or standards, practices, or conditions may violate. Doesn't hurt to put that down. Certainly needs to be part of the discussion that they're going to have with their men. The defendants need to take into account any specific requirements of the contract documents. Now, if the contract documents have some very specific things in them, like everybody's going to tie off, which to me is not particularly a good thing to say, because as you can see from some of those drawings, that doesn't make sense. Then if that isn't what you're going to do, you need to go talk to that general contractor and say, look, this isn't appropriate in this situation, and this is what we're going to do, we need to do. And you get that straightened out. And then in the next section there, you just merely state, what the problem is. You're not solving it. You're just saying this is what the problem is, and then you go forward from there to solve it. Now, when you get to the preventative or correction action, that's where you do solve it. And you say time to specify the conditions, actions, or hazards, and how they'll be handled, and can they be eliminated, or do they need to be managed? It's a good place to define and discuss various methods of remedial solutions. The discussion isn't a written one, it's one you have with your workmen. Lots of times they come up with a good way to solve the problem maybe you haven't even thought of. Then, job hazard analysis form discussion. An in-depth discussion outlines how the task will be completed and what means and methods will be employed to manage the weather-caused hazards. That can be a very simple thing, too. I know that on a lot of different areas like roofing jobs, that you say when the temperature gets below 26 degrees and or there's ice or snow, you're not going to work, just because of the fact that it's too cold to work. And to be perfectly honest, the work's going to go so slow, it makes no economic sense either. So why put somebody in harm's way for no good reason at all? and the defendants will appoint responsible supervision as the responsible supervisors as competent persons for workers' training and understand whose direction they will work. So you're going to have competent people who handle training. You're going to have competent people who handle the work, and what they need to do is to coordinate with each other. The competent person that's going to do the training not only is going to do the formalized training, but probably run toolbox talks.
Dan, we are running a little bit over time, so we're going to have to cut this a little bit short, but just so everyone knows, the PowerPoint slides will be available to everyone if we aren't able to get to that slide.
Okay, here's what we're going to do. The rest of the ones that have to do with the job hazard analysis, I think we can talk about at a later date, and I think what I can do for you here is to get down to the and just hit these on slide 47 is where I'm going. Job site safety responsibilities. The project's supervisor has responsibilities and duties. All of these things are contained in standards we talked about, the A1033 as well as the A10-1. When you put together your plans that are out there and you're doing on a multi-employer job site, those are also contained in the A1033 standard, but it's such things as safety inspections and all the paperwork that needs to go with it. Those all exist and should. The project survey and all the things we did before are also contained in A10-1. And the job safety analysis is the documentation that needs to be on the job site, any job site, as the question asked before will point out. They need to be there, and they need to be available, and that is going to be, if anything ever goes wrong, that's going to be the best way to defend what you did. And each contractor, in addition to the site-specific plan, almost everyone I know has a contractor's safety manual. The only problem with that versus what we've been talking about is that contractor's safety manual is a generic and not site-specific. Again, checklists and the other things are all contained in those other standards. Okay, the end result. If this kind of pre-planning is done, the project at every level and by every contractor, there should be no unforeseen accidents. If and when the accidents do occur, it is easy to determine what went wrong. If you use these principles to analyze your case, it becomes a lot easier to determine what happened and lay out your strategies. And if there are any final questions, I'll be willing to take them. Thank you very much.
Okay, could all the attendees please type the passcode once again into the Q&A? And because we are running short on time, we're not going to do questions right now, but if there are any remaining questions, we can email them over to you, Dan.
Okay, very good, and I'll be happy to answer them.
Okay, and this webinar is eligible for CLE credits in California, Illinois, Minnesota, Missouri, New Jersey, Pennsylvania, and Texas. To ensure that you receive your CLE credit, please complete the survey at the end of the presentation. This is a reminder that CLE certificates will be provided within 24 to 48 hours via email. In addition to being your best source for testifying and consulting experts, TASA also offers e-discovery and document management solutions, free interactive webinars, and research reports on expert witnesses such as the Challenge History Report 2.0, the Professional Sanction Search, and the Expert Profile 360. I want to take this opportunity to thank everyone for attending, and most especially Daniel Paine for his time and effort in creating this presentation. If you would like to speak with Mr. Paine, or if you would like to speak with a TASA representative regarding an expert witness for a case that you are working on, please contact TASA at 1-800-523-2319. This is a reminder that we will be sending out a link to you tomorrow with the archive recording. The archive recording will also be posted in the Knowledge Center on TASA's website. If you have any questions or comments, please email Carol Kowaleski. Thank you all again for attending, and have a great day, everyone.